Find an equation of the line that passes through the points 2, 0, and 0, 4. So we have y is equal to mx plus b. M is the slope, so that's rise over run. So we have 4 minus 0 and 0 minus 2. So that would be negative 2. Sub that into here, and we got negative 2x plus b. And then substitute either of those points to find b. So for example, when x is 0, y is 4, so therefore b is 4. And that means the equation is y is equal to minus 2x plus 4. Rewrite the equation of the line in form from A in this form. Okay, so I guess we're going to take this guy and try to make it look like that. So I'm assuming, first, let's put everything on one side. So 2x plus y is equal to 4, like that. And then I guess to get this a 1, I'd have to divide through by 4. So divide through by 4. So this becomes a 1. And this would become x over 2 plus y over 4. And although they don't specifically ask for it, I'm just going to write it out that c in this case is 2 and d is 4. State the x-intercept and y-intercept of that line. Okay, so if my memory serves me correctly, the x-intercept you get by setting y to 0. And when you do, you get x is equal to 3. So that's basically the point 3, 0. And to get the y-intercept, you set x equal to 0, then that would make this y is equal to 10, or the point 0, 10. All right, that completes that. And then part D here, determine the equation of the line that passes through 8, 0, and 2, 3, written in that form. Okay, so same thing, pretty much identical. So you should be able to do this by now, but I'll do it in case you don't know how. M is going to be rise over run, so the same story. Let's see here, 3 minus 0, and then 8 minus, or 2 minus 8, rather. Don't make that mistake. So that's going to be 3 over negative 6, which is negative a half. So that means that we have y is equal to negative a half x plus b. Now to get b, substitute either of those points. Doesn't really matter which one. I guess I'll substitute the 2, 3. So when y is 3, we have 2 for x. And then when you solve for b, I guess b is going to be 4. So that means my equation is y is equal to minus a half x plus 4. Okay, so we want to get it in this form, right? Okay, no problem. So first let's put everything on one side. So x over 2 plus y is 4. And I believe you'd have to divide through by 4 since you want this to be a 1. So that's going to make this x over 8 and y over 4 is equal to 1. And just we can complete this by stating that in this case E is 8 and F is 4. A thick red candle and a thin green candle are 100 meters tall. These two candles are lit at the same time. As the candles burn, their height decreases at constant but different rates. The red candle takes 600 minutes to burn completely. The green candle takes 480. Okay, so how much will the height of the red candle decrease 180 minutes after being lit? Well, for part A, we have 180 minutes, and the total for the red candle is what? Right here, 600 minutes, right? So this is how much in terms of a percentage, and that's 30%, right? 0.3, so it's 30%. So that means 30% of the candle will have been burned. And the candle is 100 centimeters tall, so that basically means that if 30% have burned, by how much will the height decrease? So I guess this 30% of the total height, which is 30 centimeters. Yeah, that's it. Okay, part B. How many minutes after being lit will the green candle be 80 centimeters tall? Okay, so 80 centimeters tall, that means that 20 centimeters has been burned, right? Because it's 100 at the beginning, and it's going to be 80, so that means 20 has burned. So 20 over the total, which is 20%, is going to be the same ratio for the time. So the time for this is what? The green candle this time. The green candle takes 480. So how much of that 480 minutes has elapsed, basically, is what they're asking. So we just solve this. So this is 1 over 5. This is x over 480. And therefore, x is going to be 480 divided by 5, I believe. And that means that x is, what is that, 96, I think? 96 minutes. All right, moving right along. C. How much taller will the red candle be than the green candle 60 minutes after they are lit? Okay. So 60 minutes. So this first thing is 60 over 600. That is that, what's that? 600 is the red candle. Yeah. So the red candle, this is the red candle, just put a little R there. So that's 1/10 of the time. So that means 1/10 of the candle will be burned. So 1/10 of 100. So that means that's 10. So 10 centimeters of the candle will be burned. So that means 100 minus 10 is what is remaining. So that candle has 90 centimeters remaining in terms of its height. Now we'll do the exact same thing for the green candle. It's 60 minutes, but this time we have to use 480, right? Yeah, 480. Okay, so 480 is the fraction of time, and I believe that is 0.125, 12.5%. So that's how much of the 100 meters are gone, or burned rather, I should say. So 12.5 centimeters are burned. So how much is left would be 100 minus that 12.5, which is 87.5. And now we just have to compare these guys. And when you make a comparison, you notice that the red candle is 90, the green candle is 87.5. So that means that the red candle is 2.5 centimeters taller than the green candle after the 60 minutes. And I think that completes that. How many minutes after being lit will the red candle be 7 centimeters taller than the green candle? How many minutes after being lit will the red candle be 7 centimeters taller than the green candle? Okay, so I think that is identical to the question we just did. The only difference is that we kind of have to go backwards here. So I'm going to use the exact same. I think there might be other ways of doing this, but since I already did it this way, I'm just going to keep that kind of system. I don't see why I would do anything else. Okay, so the first thing, of course, is to start at the end, and then we'll work backwards. So here, you know how this was 2.5. This time we're told it's 7. So we have 7 centimeters this time as the difference between this guy and this guy, this guy and this guy. So we don't know what they are, so I'm just going to call them x, and then x plus 7. So then we move back to here. So basically just retracing my steps. So that means that 100 minus this, so 100 minus 100 minus this x plus 7, which I guess is 93 minus x. Yeah. So that would basically represent this right here. This number right here. This guy. So that means that 93 minus x is 100 times this fraction. Now, with this fraction, we don't know yet, so I'm just going to put f, or f1, I guess. And we do the exact same thing over here, retracing our steps. So the same thing. This time we only have x. So it's 100 minus x this time to represent, I guess, to represent this number right here. So 100 minus x is basically equal to 100 times this second fraction, which is f2. So hopefully that's not too confusing. I just retraced my steps. And now we get into this part here, this guy and this guy here. Okay. So the fraction on here is f1 is equal to 93 minus x over 100. And the fraction over here, f2, is equal to 100 minus x over 100. Correct? All right. Now, we know that this fraction here represents this guy, and this fraction here represents this. And both of them are equal to something over 600 or something over 480. And that something is the same. That's the good part. So if we put that together, that means that something, I'll just call it m, over 600 is 93 minus x over 100. And that something over 480 is 100 minus x over 100. And there you go. At that point, it's just two equations, two variables, and now you can solve them. So let's do that. So this m and this equation becomes 93 minus x times 6. And this m over here becomes 4.8 times 100 minus x. Correct? Okay, so now we set them equal to each other. So we have 6 times 93 minus x is equal to 4.8 times 100 minus x, like that. Let's solve for x now. And after some basic algebra, you get x equal to 65. So then we just have to go back and calculate m. And when you do, you get 93 minus 65 over 100. And that is times 600. Where's the m? Yeah. Right here, times 600. And when you do, you get 168. So 168 is the answer to this question. I know it's a little bit longer than what you had hoped, but I just wanted to follow this one up here. Now, if you have a quicker or faster way, then, that's perfectly fine. The even positive integers are listed in order and arranged in rows as shown described below. Each new row includes one more integer than the previous row. The last number in each row is the product of the row and the largest next integer. For example, the last number in row 4 would be 4 times 5. List the numbers in the 7th row of the table. All right. So we have row 1, row 2. I think we squeeze it in here, 6 and 7. So let's see here, 22, 24, 26, 28, and one more, right? 30. This will be 32, 34, 36, 38, 40, and 42. Then we have 44, 46, 48, 50, 52, 54, and finally 56. So 56 is, I believe, what they're looking for. Just list the numbers in the 7th row. Okay. And I want to point out this point here. The last number in each row is the product of the row number less largest. That's very important. So what do they mean by that? So for example, this is the last number in that row, right? It is the product of the row number, which is 7, times the next largest number, which is 8. 7 times 8 is indeed 56. Let's look at 42. It is the product of the row number, which in this case is 6, times the next integer, which is 7, since 7 comes after 6. And you'll see that that's true for every row. Okay, so that takes care of that. What are the first and last numbers in the 100th row? Okay, so now we have to do a little bit of extrapolation here. So the 100th row. Now the 100th row obviously is going to have a whole bunch of numbers, right? And let's see here. In the first row, there's 1. In the second row, there's 2. In the third row, there's 3, and so on. So in the 100th row, there's going to be 100 numbers. So 100 numbers. But they don't want all of them. They just want the first and last. Okay, no problem. So I'll concentrate on the last one. The last one is the product of the row number times the next number, which is 101. So that's a pretty straightforward way of figuring that out. And then that is 10,100. Okay. So then all we have to do is just understand that these are no, they're not consecutive. They're going up by 2s, right? Okay. So to get the first one, I've got to take the last one and subtract 99 times 2. Yeah, not 99. Okay. Gotta make sure I do it correctly. So it's 9902. That will be the first number there. Yeah. Or another way of doing it is just looking at the last number of the 99th row, which would be 99 times 100, which is 9,900. And then the next number would be 2 more. And that's why it's 9902. So either way, you should get 9902. Part C. The last number in row R is L. The first number in row R plus 2 is F. Determine the smallest possible integer value for R such that F plus L is at least 2013. Oh boy. All right, so I gotta think here. How do I do this? Okay, so let's set up the math first, and then we'll tackle this. All right, so let's see here. So we've got row number here, and then we have R, and then we have eventually R plus 2, right? Okay, so we'll put R plus 2, and then we'll put an R plus 1 in there. Might help us. And then R is going to have a whole bunch of numbers. I don't know how many, but actually I do know how many. There's going to be R numbers, because each row has the same number of numbers as the row number, if that makes any sense. And then the next one, same thing, a whole bunch of numbers. There's going to be R plus 1, and this is going to be R plus 2 numbers, like that. Okay, so they're saying that the last number in row R is L, so this guy is L. But we do know that L is going to be equivalent to R times R plus 1, according to the definition of the question, defined in the question, I should say. And similarly, this guy, this number, whatever it is R plus 1 times R plus 2. And this number, which is whatever it is R plus 2 times R plus 3 times R plus 3. But what is the first number in, oh, okay, I got it. First number in F, so this guy here. To get that, I guess you just add 2 to that. So that's going to be R plus 1 times R plus 2, and then plus 2. Yeah, okay, I got it. And then they're saying F plus L is going to be at least 2013. So F plus L at least 2013, meaning greater than or equal to 2013. Okay. And then what are they asking? Find the smallest possible value for R. Okay, all right. So I guess we have to substitute in our definition. So F is R plus 1 times R plus 2 plus 2. And then L is R times R plus 1. Greater than or equal to 2013. Ah, okay. And then we have to solve this. So this is most likely going to be a quadratic, I think. Okay, so let's try to expand this. So we got R squared plus 3R plus 2 plus R squared plus R is greater than or equal to 2013. And then this R and this R, that becomes 2R squared. That and that is 4R. And then that's 4. All right. So we have to solve this somehow. It's a quadratic. And let's see if I can simplify it. I don't think I can simplify much. 2R squared plus 4R minus 2009. Yeah. So it's a quadratic. I don't know what it looks like, but usually quadratics look something like this, right? So they want the smallest possible value of R. Okay. So that this is greater than 0. So this graph is greater than 0 here and here, basically whenever it's above the x-axis. Now R is a row number, so R has to be positive. Yeah, so this is R actually. So we're only interested in this part. So we're basically looking at where is this intercept, and then what is going to be the smallest integer greater than that. Okay, so do I have to use a quadratic? Yeah, because I really don't see how this can be factored. All right, so minus b, all that stuff. B squared minus 4ac, 2 minus 2009, right? All that. Okay, all over 2 times 2. And then I'll let you guys do that math. It comes out to minus 32.71 and 30.71. So this is 30.71. Now, row numbers are obviously whole numbers. So the first whole number after that is going to be right here, which is 31. So since r is greater than 30.71, the smallest value for r is 31, because r has to be a row number since it represents row numbers. A cube with edge 9 contains a certain amount of water. When the cube has one face resting on the ground, the depth of the water is 1 centimeter. What is the volume of the water in the cube? Okay, so volume is length times width times height. And they tell me that the edge length is 9. So that means this is 9 and this is 9. And then they also tell me that the height of the water is 1. So this is going to be 9 times 1. And that is 81 centimeters cubed would be the volume of the water in that cube. B. The cube is turned so that one edge, PQ, is on the ground and the opposite edge, MN, directly above it. Calculate the depth of the water in the cube. So here's a diagram that describes that question. And the volume will basically be the area of the base times the height. So I'll explain. So here's the base right here, this equilateral, well, I don't think it's equilateral, it might be isosceles. So the area of that triangle, and then the height, I'll just call that the height. So in this case, it's going to be 1/2 base times height of the dimensions of that triangle, and then we'll multiply it by 9. Now, the volume we've already figured out in the previous question was 81. So this just becomes 81 is equal to 9 over 2 times base times height. Okay, so now we have to concentrate on this triangle here. And because of the symmetry of this diagram, I believe it's isosceles. Yeah, I think so. So I'm going to draw that here just to make it a little bit bigger. And this is isosceles. Not perfectly drawn to scale, but that's okay. And this will be my height, and this will be my base. And therefore, from here to here will be b over 2. And similarly, from here to here will be b over 2. Now, since it is isosceles, let me think about this. Well, this is a cube, right? So this is a right angle. So that means this is a right angle. So since we're chopping that in half, this is 45 degrees in here. And since this is a right angle, this is 45 degrees. Yeah. So we got to use a little bit of trigonometry here. And since that's 45 and that's 45, that means that this side is the same as this side. Yeah, that also becomes isosceles. So that means that b over 2 is equal to h. Okay, so that's very helpful. So now I can sub that into here. So now 81 is equal to 9 over 2. So what are we solving for? H in this case, right? So instead of putting b, I'll put 2h, since b is equal to 2h. And then this is h. So now this just becomes 81 is equal to 9h squared. That means h squared is equal to 9, and therefore h is equal to 3. And that solves the question. Part C. The cube is now positioned so that the single corner P is on the ground and the opposite corner N directly above it. To the nearest hundredth of a centimeter, calculate the depth of the water in the cube. So this time our 3D geometry is a little bit more complicated, and they do not give this diagram on the question. This is something that I got from the solutions. So you unfortunately have to figure this out on your own. So it's obviously challenging, but I'll try my best to explain it. Now this shape here that is RTSP, I'll draw it here because I want to explain it and I don't want to make the diagram too messy. RTSP, something like that, right? Yeah. All right, so we got T, S, R, and P. Now, can you tell me what is the shape? What is this? Is it a triangle? Is it a square? No, it is a tetrahedron, and tetrahedrons are oftentimes tested on math contests because they usually have to do with a slice or a cross section. Okay, so the first thing I must convince you is that in this tetrahedron that is in that diagram that I've also drawn up here, by symmetry, there's a few things that will be very helpful. And the first thing is that the sides are the same. So PR is equal to PS is equal to PT. If you were to draw lines from P to R, from P to S, and from P to T, they will all be similar. And I know in the diagram it doesn't look like that, but this should be R and this should be P, by the way. And that is going to be the same. Now, we don't know what it is, so I'm just going to let it equal Y for now, and then we will try to solve for it. Now, to make this a little bit more digestible, what I'm going to do is I'm going to rotate this tetrahedron, this guy right here, and I'm going to put it on its side like this. So I'm going to put it kind of like this. So this is now R, this is now P, and this is now S. And then in a way, I've got to draw the other side. And let me see if I can do that. There you go. And that is my T. And these are all right angles, so this is a right angle. This is going to be a right angle. And that is going to be a right angle also. So like that. Okay, so now let's label this. This is Y, right? Because RP is Y, PS is Y, and PT is Y. So that from P to T is also Y. Now you say, well, why did you draw it like that? Because now I can calculate the area. I can calculate the area of triangles and the tetrahedron. So the volume of a tetrahedron is as follows. It's 1/3 times the area of the base, whatever you choose as a base, and then you multiply it by the height. So in this case, I will choose the base to be just triangle PRT. Yeah. So I'll choose this to be the base. That to be the base. And then since that's flat on the ground, the height can be from P to S. So therefore the volume is going to be the area of the base. And the area of the base, this is a right angle. And I know it doesn't look like that, but it's going to be a right angle. And therefore the area would be 1/2 base times height. So in this case, it's Y times Y. And then the height is this guy, this Y. So there you go. And then the volume, we know from the previous question, was 81. So this becomes, let's see here, Y to the power of 3. Oh, sorry, this should be 1/3. So Y to the power of 3 over 6. Yeah. So Y is 6 times 81, which is 486. And then you take the cube root. Okay. So we figured out Y, which is very helpful. But we have to now figure out the height. Basically this top to bottom, sort of that kind of top to bottom. And that's where the next diagram comes in. Keeping that in mind. So now what we've done is we've taken this and kind of put it in a different rotation, and that allows us to figure out the height. Now, one thing is this triangle now, RTS, is equilateral, right? Because if you remember, this has symmetry, and that allows you to figure out that this is an equilateral triangle. Now, we can use Pythagoras to figure out what is R to S. Because if you remember, PR and PS are at right angles. PR and PS are at right angles. That's a right angle. So RS squared is equal to RP squared plus PS squared. So RP, if you remember, we had denoted it as y, and PS was also y. So RS squared is 2y squared, so RS is a root 2y. And since it's equilateral, that means that our values for RT are also root 2y, and TS is also root 2y. Okay, so now let's go to the volume of the tetrahedron. Remember, volume of the tetrahedron is 1/3 area of base times the height. So in this case, we know it's 81 from the previous question. Area of base, we're going to use this as the base. That triangle, RTS, which is equilateral. And the area of an equilateral triangle is root 3 over 4 S squared, where S is the side length. And the height is that guy, that H, which is what we're trying to figure out. All right, so we're in the home stretch here. So let's see here, we have 81 is equal to 1/3 times root 3 over 4. Our S is the side length, so this is S. So S squared should be 2y squared, and then H. And then y, in the previous question, we had figured out, if you remember, this is root 3 over 12 times 2. In the previous question, we had figured out y to be the cube root of 486, and that's squared, and then H. So there you go. We have all numbers, and I'll let you calculate H. And when you do, you get H is equal to 4.539, and to the nearest, what did they say? I think 100th of a centimeter. It'll be 4.54 centimeters. And that completes 4C.